comparison of two quantities. Ratio is the comparison of two quantities. Including Schluckaway and myself, there are 9 boys in the classroom and there are 8 girls. So if I want to write a ratio of boys to girls, I could write it 4 different ways. I could say it's 9 to 8, boys to girls, using the word 2. You could say the ratio is 9 to 8, using a division symbol. You could say that it's 9 to 8, using a colon. Or you can say that the ratio is 9 to 8, using a fraction bar. Most commonly, you see it using the word 2 and a colon. Math, we're going to use the fraction bar mostly. And since it's a fraction, it's always going to have to be written in what type of a form? Fraction form, but you always write your fractions how? Simplest form. Good. So we always have to make sure we can reduce it. This one I can't. 9 to 8 is all I can do. All right? So number 1, we're going to write a ratio here. It says a scale model of a car is 4 inches long. The actual car is 15 feet long. What is the ratio of the length of the model to the length of the car? You have to read carefully, like you always should, but you have to make sure you're following the order. It says they want the length of the model to the length of the car. So how long is our model? 4 inches. 2, I'm going to use my fraction bar there. The length of my actual car? 15 feet. Can I reduce it? Well, if it was in inches, what do you mean? Good, you should. When you're comparing this, you need to have them in the same unit of measure. So we need to get them both into inches. Trevor, how many inches are in a foot? How many inches are in a foot? There you go. So you took it times 12? Good. So then this would be 4 inches to 180 inches. When you write a ratio, you want to compare two quantities, but they have to be of the same unit. Now can I reduce it? Yeah, they're both even numbers, right? Well, it means 2 goes into it, so 2 over 90. Can I reduce that one? What? Good, 1 to 45. 45. So compare like quantities, they have to be of the same unit of measure as well. Number 2. A photo that is 8 inches wide and 5 1/3 inches high is enlarged to a poster that's 2 feet wide and 1 1/3 feet high. What is the ratio of the height of the photo to the height of the poster? Again, you got to read carefully, look at what they're asking you to find. Height of the photo. Lynn's, how high was our photo? Good, 5 1/3 inches. How about the height of the poster, Lynn's? Good, 1 1/3 foot. So there's our starting ratio. Now we're going to have to go through and simplify this. Before I can simplify it, what do I have to make sure? They're in the same unit. Good, Brian. So what are we going to do to convert our feet to inches? Okay. Brian, what's 1 times 12? What's 1/3 of 12? So then 12 plus 4 gives me how many inches? Good. 1 1/3 feet is the same as 16 inches. All All right, so now we have it both in inches, but this isn't simplified because you can't have a fraction within a fraction. Right, Linz? Okay. I don't have a calculator, so I'm going to show you how to do it without my calculator. You have to turn your numerator into an improper fraction first. So that's when you take your denominator times your whole number plus your numerator. So 3 times 5 plus 1 gives us what? 16. Good. So this would become 16 thirds over 16. Still a fraction within a fraction, but this makes it easier to work with here. 16 thirds over 16. This over, what math operation goes with that? Division, right. So I'm taking a fraction and dividing it by a number. Well, instead of dividing fractions, what can we do? Louder, Brian. Good. Multiply by the reciprocal. Dividing fractions, multiply by the reciprocal. So you're going to take 16 thirds and multiply by the reciprocal. What's the reciprocal of 16? No, of 16. 1/16. Good. Remember in middle school they say same change flip, you flip the last one. And then when you multiply fractions, you just go straight across. 16 times 1 is 16. 3 times 16 is 48. And then that would reduce down to 1/3. Pretty neat, huh, Spence?
Are there questions like this on the assignment? Or you have to narrow it down like to the...
Well, there are ones where you have to convert today. Today there won't be any with mixed numbers. But there will be next week. Possibly on your quiz on Friday, even. So maybe you want to put a star next to that and like write quiz next to it so you remember to go back and look at that one. You could practice doing it by covering up the work that you just did. Okay. All right. So a ratio, comparison of two quantities. If you have two ratios and you set them equal to each other, it's called a proportion. So we're right there next to the middle hole punch on your paper. Proportion. Two ratios set equal. There's two examples below your definition. The first one written as two fractions, a over b equals c over d. You can read it as saying a is to b as c is to d. Same with the colons. A is to b as c is to d. Those are two proportions when you have ratios set equal. An extended proportion is when you have three or more ratios set equal. So two ratios, proportion, more than two, extended proportion. And there's an example there with the numerical fractions, numerical ratios. Solving a proportion, you use your cross product property. Cross this off for a second. A is to B as C is to D. That'd be the same as saying A is to B as C is to D. Okay. The cross product property states that the product of the extremes equals the product of the means. Product of extremes equals product of means. The means and extremes that they're referring to, those are the parts of the proportion. When you hear the word extremes, or if you just look at its prefix, what does that prefix mean? You know, like you think of the word exit or exterior. What do you think of? The outside. Good. Extremes. Those are the outer parts of your proportion. The means are the terms in the middle. So your extremes are going to be your outer terms. Your means are going to be your middle terms. When you write it with a colon, which two terms are on the outside of this proportion? A and D. Those are your extremes. Which two are in the middle? So these are your means. When you have it written as two fractions, which is how you're going to see it, your extremes are still on the outer. They're just the very first part of the proportion, and it's the very last part of the proportion. And then your means are your other two terms. So the cross product property says you can multiply your extremes, A times D, and that equals the product of your means, B times C. And it turns into a linear equation that you can solve from there. That's what you use to solve proportions. Cool. Flip. At the top here, properties of proportions, you can rewrite proportions different ways. So they give you one at the very top, A is to B is C is to D, and you need to write the equivalent forms that they have started for you. It's like finding the pattern. So taking the first one and figuring out what they did to get this first part. So A is to B is C is to D, then AD would have to equal what? CB. Good. 2, you're still using the original one, and then you're finding the new pattern from that. So A is to B is C is to D, B is to A, D is to C. Do the next two. Bree, what'd you get for the third one? A is to C is what? Good. B is to D. Ross, how about the fourth one? A plus B is to B as? It's what? Over D. I just didn't hear you. Good. All right, so equivalent ways to write them. And go ahead and do the number 3, the next one. I think most of you already did right below the box. Complete. If A is to 4 as 12 is to B, then B is to 12 as what? Did I already have it up? 4 is to A. To check if these are equivalent, you use your cross product property. So if I cross multiply my first one that they gave me, A times B is AB. 4 times 12, 48. When I cross multiply the second one, we should get a similar equation there. B times A equals 48. Those are the same. A times B and B times A are the same. So you know that you have it correct. Okay, number 4. Actually solving the proportion, solving for the variables in here. First one, 2 is to 5 is n is to 35. Cross multiply the extremes, those are your first and last terms. So you do 2 times 35 equals the product of your means, 5 times n. And what's 2 times 35? Equals 5n. How do we move our 5 over? Brian, you got it? What is it? Thanks. He's my human calculator, Mr. Schleckler. Yeah. You can solve these to review. It's algebra, so you can plug them back in, not solve them, check them. 2 over 5 equals 14 over 35. Just like we checked this one by cross-multiplying, you can check these ones by cross-multiplying. 2 times 35, 70. 5 times 14, 70. If they both equal each other, then you have the correct answer. See that? Okay. B. Go ahead and try B. All right, some of you are on, and then some of us are just forgetting. I think if I put parentheses around it, you would know what to do then. Brief, I'm going to multiply the extremes. Which parts are my extremes in the proportion? Yeah, and I'm supposed to multiply them together, right? So I'm going to put my x plus 1 expression into parentheses. Gracie, my means then have to be which ones? Good, so that would just give me 3x. What do we have to do with this 2 now? Distribute it through. So then you'd get 2x plus 2 equals 3x. This is where we were forgetting. If you do this in your head, this extremes, a lot of times you forget to distribute to the second term. So if you write it out, you can see that you have to distribute there a little better. Subtract 2x over, and you get x to equal 2. Spencer, plug it in and check. What's 2 plus 1? So 3 over 3 and 2 over 2. Are those equivalent fractions? Because they both reduce to what? Good. Awesome. Okay, try C now. Nick, which terms should I multiply together? And which one? Okay, equals. Awesome. Distribute your 6 through. 6n plus 36 equals 18n. Subtract 6n to the right. 36 equals 12n. Zach, divide by 12, and what do we get for n? 3. Did you check it? Does it work?
Yes.
Did you really? Are you right now? Good, and it works? Good. Awesome. All right. Questions on those proportions? Great. Skip 5 on yours. We're going to go to 6 for a second. We'll come back to it. We'll come back to it. We're skipping it for a moment. So on number 6 here, a map uses the scale 1 centimeter equals 20 miles. A county is 90 miles wide. How wide is the county on the map? So for every 1 centimeter on the map, that's 20 miles on the actual road. That's what we're telling us here. I'm sure some of you can just look at it and calculate in your head how long it's going to be. But I'm going to show you how to set up a proportion to do it. Trevor, do you remember what a proportion is? What is it?
It's a ratio set equal.
Good, 2 ratios set equal. They give us one ratio, 1 centimeter for 20 miles. That's my starting point. Equals, now I have to come up with another ratio. X over 90? Why not 90 over x? Excellent. You have to compare like parts. So if we put miles in the denominator the first time, then I got to put the miles in the denominator the second time. How do you solve a proportion? Cross multiply. So you don't need to worry about the labels here. You just multiply the numbers. 90 times 1 is 90. 20 times x is 20x. Divide by 20. The zeros cancel. What's 9 divided by 2? 4, yeah, 4.5 centimeters. So the 90-mile wide county on real life is only 4.5 centimeters on the map. That's what it's telling us. All right, Alyssa, back to your extended proportion. Are you working on it? Oh. You finished them already? How did you start them? 2 equations? Why? Oh. Okay. So which 2 did you do first? Or like what equation did you come up with first? So you multiplied the first 2 together? Okay. Good. An extended proportion, like on the front side, just has more than 2 ratios. You still use cross multiplication, but that only works with 2 ratios. So you just pick 2 ratios out of the 3. Alyssa, why wouldn't you pick like the last 2 to solve first? Good, because there's an x and a y. And then we have an x and a y in one equation, so pick one that has the same variable in both of them. Did you get down to 15 equals 6x? Yeah? 3 goes into both of those, so that would be 5 over 2. Oh, you did? What'd you do? Did you forget to distribute your 3 through? Dang it. But hey, good starting spot. Yeah. Okay. Do you agree with me, 5 over 2? For my answer?
Yeah.
Just nod your head, yes.
Did it wrong.
No, Alyssa forgot to distribute her 3 to the 5.
So that is it?
Yeah.
Oh.
Yep, this is right. What's 5 divided by 2 for you decimal people? 2.5. You can write it either way. Okay. But how are we going to find y now? Substitute x back in. So then I would have 2.5 over 3 equals 7.5 over 9 equals 5 over y. So I have to use the last one since I'm solving for y. And then you can just pair it up with one of the other two. Thanks, Morgan. Do you want to do the first and the last or the middle and the last? It's your choice. It doesn't matter. The last two? All right. So we're going to cross multiply 7.5 over 9 equal to 5 over y. So this would be 7.5y equals 45. Yep, divide by 7.5. Nick, I don't have a calculator up here. So instead of dividing with decimals, I like to turn them into whole numbers. So I'm going to move my decimal place over. And that would become 450 over 75. Those are equivalent fractions. Now to me, that looks like money. How many quarters goes into 75 cents? 3. So I know that this is going to become a 3. How many quarters does it take to make $4.50? Mm-hmm. 4 times 4? Awesome. And what's 18 divided by 3? 6. Good. Yeah, I won't write anything, or I won't go on. And those of you that have a calculator, I'm sure you already had it because you just punched 45 divided by 7.5 in. Yeah, after we figured out what x was, we substituted it in. And I could have also, Gracie, done like these two and cross-multiplied them. Mm-hmm. Yep. I had to pick these two to start because those two each had only an x in it. I didn't want to start with the last ratio because there was an x and a y. Do you know what I'm saying? Okay. All right. If you haven't already, start or do number B, do the second part of it. Kendra, which two of the 3 did you choose first to solve? Good. So when I multiply the extremes, 3 times 27, we get 81, right? And y times y is y squared. Good. Anytime you take something times itself, it's called squaring it. So this would be y squared, not 2y, y squared. What times itself gets you 81? 9. So y would equal 9 then. Take the square root of both sides and y equals 9. Substitute it back in. Get x over 7 equals 3 over 9 equals 9 over 27. Gracie, it wouldn't matter here which two you pick then after you figure out one of the variables. I'm just going to pick the first two because they have smaller numbers. Okay, so cross multiply. 9 times x is 9x. 7 times 3, 21. Divide both sides by 9. How many times does 3 go into 21? No, how many times does 3 go into 21? 7. Good. How many times does 3 go into 9? 3. So 7/3. Or that would be 2 1/3. Or if you must, 2.3 repeating. You don't stop at 2.3 because 2.3 is not the same as 7/3. Okay. 2.5, like we got on part A, that's a nice decimal. Nice decimals are okay. 2.3 repeating, that's not a nice decimal really, so you can leave it as a fraction. Questions on those? Okay, the last one I have for you is not on your notes, but you still need it out because you have to write.